The purpose of this lesson is to teach equality of decimals and place value with visual models in order to teach these concepts with understanding. Students can be shown this square for the decimal 6/10 and asked to find or describe the hundredth square with the same shaded amount and write a decimal equality for the two squares. The hundred squares have heavy vertical lines and horizontal lines that aren't so heavy, and these heavy lines help students to think in terms of columns. So both squares have 6 4-columns shaded and their decimals are equal. There are 9 such pairs of red squares for tenths and green squares for hundredths whose decimals are equal. Here is their list of equalities. Students are quick to see the pattern here of adding zeros, but often when given such equations, they cannot explain why a zero can be placed at the end of a tenths decimal to get an equal hundredths decimal. For example, they might be asked to explain why 3/10 is equal to 30 hundredths, or 0.3 is equal to 0.30. Using a visual model, such as we have been using, and the meaning of decimals, 0.3 means 3 parts out of 10, and 0.30 means 30 parts out of 100, and these two amounts are the same. Another activity is finding all red squares for tenths and yellow squares for thousandths with the same shaded amount and writing an equality for their decimals. One part out of 10 and 100 parts out of 1,000. Such pairs of decimals can also be listed with an obvious pattern. Some pairs of green squares for hundredths and yellow squares for thousandths have the same amount of shading. 5 parts out of 100 has the same amount of shading as 50 parts, 10, 20, 30, 40, 50 parts out of 1,000. So, their decimals are equal. There are 19 pairs of hundred squares and thousand squares with equal decimals in this deck. This shows the beginning of that list. The number of full columns shaded is 4, the same amount of shading as for the decimal 4/10. So we say 4 is the tenths digit, or in the tenths place. The number of small squares, 1, 2, 3, 4, 5, is 5, the same as in the decimal for 5 hundredths. So 5 is the hundredths digit, or we say it's in the hundredths place. This square has 325 parts out of 1,000 shaded. Its decimal is 325 thousandths. But we can think of each of these digits separately. The 3 is for the number of full columns. So 3 is a tenths digit, and we say that 3 is in the tenths place. 2 is the number of small hundred squares. So we say 2 is the hundredths digit, and 2 is in the hundredths place. Finally, there are 5, 1, 2, 3, 4, 5 tiny thousandths parts. So 5 is called the thousandths digit, and it's in the thousandths place. Place value tables are a common method of recording the digits in decimals. For a table with 4 tenths, 2 hundredths, and 5 thousandths, the decimal would be 425 thousandths. For a table with only 8 in the first column, the decimal would be 0.8. The table for the decimal 0.8 might look like this: 8 full columns shaded and 0 hundredths squares shaded. Or the table for 0.8 could look like this: 8 tenths, 0 hundredths shaded, and 0 thousandths shaded. When we look at inequality of decimals and operations on decimals, there will be times when we want to include the 0 in the hundredths column and 0 in the thousandths column to represent the decimal 8 tenths. Conversely, given a table, students can describe the corresponding square for the decimal. In this case, it has 7 full columns, 0 small hundredth squares, and 4 tiny thousandth squares. There are 2 interactive games at decimalsquares.com that are related to this lesson. In the game Concentration, the object is to turn over 2 squares whose decimals are equal. In this example, the decimals are not equal. The second game is played against a robot with players spinning a spinner and placing numbers in either a 3-place or 4-place table. Students often learn rules for equality of decimals and place value by rote methods. But this lesson has shown it is possible to teach these concepts with understanding.